Okay, so just to preface this, this is not a we're getting async soon. In part because I am asking Modular to rip up a decent chunk of what is currently there and start over. Um, so just kind of to get that out of the way, this is a start of discussion proposal, not a something we're going to have within the next month or two proposal. So this is kind of the classic motivating example for asynchronous I/O, but updated for the modern day, which is how do you serve 1 million concurrent users from a single server? So let's simplify it a little bit. Assume each user needs to have a single number or other trivial amount of data sent to them once per second, and that they stay connected. 1 million threads. Um, Here's a hint. On Linux, you want 10 terabytes of memory. What if we make the stack smaller? And what if we decided to also handle scheduling ourselves? Because most operating system schedulers won't handle 1 million threads well. And what if we only ran them when it was time to send an update? And actually, the compiler knows how big things are. So let's use exactly the right amount of stack space. Congratulations, we have coroutines. So what happens when you write async function is the compiler takes that call tree and converts it into functions around yield points where the coroutine suspends. And it says, okay, everything before the first suspend point, that's one function. Everything from the first to the second, that's another. And what it lets you do is you call the function, and then it will yield something back, which is a return from that function the compiler created. And those yield points are where you want the coroutine to stop running. So that's sleeping. That's waiting for I/O to finish. That is some other thing that you've decided, waiting on a channel. And what this means is that coroutines act like threads which voluntarily stop running when they have nothing to do. And there's a lot of kinds of coroutines. There's stackless coroutines. This is what C++ and Rust have. And this is the true as much memory as the task needs. There's no real waste. And Rust has kind of split this into, I will explain a little more later. And then there's stackful coroutines, things that most people don't hear described as coroutines very often. And that's where you allocate a small stack and then you just move the stack pointer to that. It's easier on the compiler, but you have to have an actual stack. So it starts running into the same problem as earlier things do. So Go routines are actually coroutines that the compiler is very, very good at hiding from you. Java virtual threads, also coroutines. So how do you do async await? You have yield, and that's that yield point. It's return the value, in this case x, from the current subfunction. And then you have return. That is finish the coroutine, it is done, it is safe to free it. And then there is await. So await, when you await another coroutine, is actually saying for everything this thing yields, yield that too. And then the compiler looks at that really long chain, says, okay, I know what you're doing, and collapses all of it into one place. And then await gives you back the return value. And then there's a really big loop at the top, which runs all of these subfunctions until coroutines are done, with varying degrees of intelligence from keep running the first thing until it's done and continue, which isn't terribly helpful, up to complicated AI-driven scheduling policies. Not pictured is 67 years. That was an interesting fact. Coroutines were actually invented in the 50s. So, one of the key parts of Wakers, in order to make the scheduling not a complete nightmare, is Wakers. And these have various names in different languages. But it's essentially a handle into the scheduler, usually implemented as a vtable and some data to identify the task if you need to do that. Um, so the Wakers is Rust parlance, C++ coroutine handles, similar thing. And essentially what you want is you want a coroutine to arrange for the .wake function to be called on a waker when the coroutine will have more work to do. So this means if you do I/O, whichever thing is managing all of that I/O will wake you up when the I/O is done. If you're waiting on a channel, something which puts data into the channel will wake you up. We also probably want a way to do busy polling. Um, there's a way to do that with coroutines where you say, I promise I didn't use the waker, just put me back in the ready queue. And that is essentially free and fixes a great annoyance many people have with Rust. So let's take a more practical example here. A task wants to do some I/O, and it submits a request to a subsystem, in this case an IOU ring subsystem, and this request contains a waker and the operation it wants to do. So it will have the waker and say a read request, as well as a place to put the IO back, which is likely a location inside of the coroutine. This could be direct function call, or it could be message passing. Depends on how you want to implement it. It's library dependent. And then the waker, as well as the data needed to collect the IO request to the response, is stored. And the subsystem continues to do its thing until the kernel says, hey, that's done. And then it gets a completion event back, which matches the request. So the IOU ring subsystem task fills out the result struct and uses the waker to tell the executor, hey, you can schedule that coroutine again. epoll, which is the more common but slower API, is very similar. There's a little more bookkeeping because of some of the way that epoll works, but more or less the same. Um, and this also lets you do fancy things like wake up a task when you send Control C to do graceful shutdowns. So now we get into Rust futures. And this trait is a little messy. So as a brief translation, the type output is very similar to what we have now. It just says there is a type attached to this, and that is what the coroutine will return. Um, and then what the coroutine type that the compiler has created will actually do is it will wrap that in a poll struct, which either says I am still working or I am done. And that enum is what is yielded up to the executor. So here you have a reference to pin of the future or usually coroutine. Pin is something Mojo doesn't need because Mojo has move constructors, so that can go. Context in Rust only holds the waker, but it gives us a place to put more stuff if we want to expand the API later. So, why I think Rust almost got it right. So, there are no forced heap allocations. You can work entirely within the stack. Rust async will work perfectly fine on a microcontroller. You could technically bang it into a shape where it will work on a GPU as well. And wakers provide an interface between executors and libraries, but it's not a direct and concrete interface. So there's some abstraction there, which makes it a lot easier to build executor agnostic async libraries. And this means you don't need to expose, for instance, a well-known location of scheduling queues. in order to wake things up. And this is generally good for the standard library to not break stuff whenever we find a better way to design things. Using traits gives a lot more freedom in terms of compiler layout compared to C++, which says you need to inherit from this class. And you can implement future by hand, which lets you easily bridge synchronous code that wants to be busy pulled, where you can just wake yourself up, assuming the executor allows it, which is kind of undefined behavior in Rust and something we can fix. Now, there's also a bunch of stuff that Rust got wrong. So the ecosystem decided that work stealing is a good default, which means all tasks have to be thread safe at every single await. And that's because at any await, you can be moved between threads. This is what causes, if you've ever seen the arc mutex t all over the place in async code. That is part of why. And the other reason is that Rust doesn't have a sound way to represent scoped tasks where you say, I'm going to spawn off these three things, and they are either going to execute directly on this thread or maybe on other threads, but I am not allowed to continue until all of those are done. Rust does not have a sound way to implement that. Linear types solve this. So that works out very nicely. And I think these two are the cause of most of the complaints about Rust async, because this is your send plus sync plus static bounds. You must be thread safe, your reference must be thread safe, you must live forever. And then the lack of scoped tasks means the compiler loses the ability to reason about a lot of lifetimes. So things get even more messy. Cancellation is a mess in Rust. I have ideas for that. Try await, try yield. I don't think that we really need to go into that now. That's for another proposal. And then standard abstractions don't exist for common async functionality. There is no standard async sleep in Rust. There is no standard spawn task. So, and this causes problems with portability between executors. We can fix that. And the other big issue is there's no way to write code that says, I don't care about asyncness. Meaning that libraries oftentimes will end up forcing users to learn async to do basic tasks because the libraries want to be compatible with more enterprisey development, which actually needs it. Whoops. So I have another solution which uses effect generics and an effects system to help with that, but that is technically orthogonal. So how do I think Mojo can do better? On a language standpoint, let's start with Rust's async. It's the most widely tested async of any systems language because C++ only very recently got async, and it hasn't gotten anywhere near the level of adoption that Rust async did. So for context, for C++ only people, it is difficult to find an HTTP library that is not async in Rust. Throw out pin, we have move constructors. Add a scope task API using linear types. That gets rid of a lot of that reference counted mutex of thing. In the library and ecosystem, don't do work stealing by default. This removes that you must be thread safe, your reference must be thread safe, and you need to live forever bound from most APIs. We can add it back as something you opt into to say, I would actually like to schedule that on another thread if one is available. And then that's the only time you have to deal with API bounds like this. And then a standard library executor with a strong capability-based trait interface. Put the executor entirely behind that to give people the ability to plug in their own And this prevents the standard library from having to support everything under the sun. So there are all sorts of use cases with, say, hard real-time guarantees, or if someone wants to use a really, really weird API, or if they have hardware accelerated scheduling, which everyone who bought one of the new Xeons does. These are things we don't really want to deal with in the standard library, but are useful to have available if you want them. And then to the standard library executor have pluggable subsystems to handle different I/O APIs. We can ship with some of the basic ones and then add a way for people to have their own. So this would be your BSD sockets API, which isn't really async, but there are other parts of POSIX that make it async-ish. Your ePOL, your IOU ring, your KQ, your IOCP, your ASIO if you really want to do that, and allows you to plug in async from various devices. For instance, async CUDA kernels. And that is all I have. I wanted to keep this kind of high level so it's more accessible. And I will cut over to QA since I went a little over time.
Awesome. Thank you so much, Owen.
Yep.
Any questions from the group? I have a question, maybe kind of basic. So does this proposal require us to implement linear types before this could be implemented?
So the only real thing that requires linear types in this is that scoped task API.
Mhm.
So it that can be put off for later. It just means that some types of code will be slightly more annoying to write.
Mhm.
I think you could add that in a backwards compatible manner
Yes.
as well. All existing tasks that don't rely on that behavior would function just fine in that kind of environment once you add it.
Yes. Yep. Evan?
Evan?
Yeah, so you mentioned that we can throw out pin because we have move constructors. Can you explain how that works?
Yeah. So pin in Rust means it is used for unmovable types because Rust doesn't really have linear types or move constructors. So, and coroutines are almost necessarily self-referential. So what Rust's workaround is that there is a pin trait, and when you pin something, you go fix all of the pointers as if you had used a move constructor. And it's a kind of ugly workaround to Rust not having move constructors. It technically saves a very, very small amount of cycles because it means that you don't fix up the pointers until you need to, but that is a very, very small amount for a substantial loss in ergonomics.
It effectively means that after the initial creation of your coroutine, they are functionally immovable until they are canceled or eventually complete, which means that the executor doesn't have as much flexibility in manipulating any of them.
And you can't do hot start. Yep. Connor?
Yeah, I just want to actually add a bit of background. I also want to say this is an awesome presentation, Owen. Really great job on this. I'm super excited about this.
Thank you.
But a little bit of background for folks who don't understand why pin comes up in the first place in async. The answer is that the structs that the like an async function typically that's compiled down to, they often have it's very easy to get self-referential pointers. So you have a struct that has a field that is a reference that wants to be able to point to another field in the same struct. That's impossible in Rust because it has no way to reason about what it means if you were to move that struct to a different location in memory. When Owen, I think, said earlier about fixing up the pointers, that's that's this idea that if you have a struct that's self-referential, if you can run logic at the time that you move it in memory, you can update the address that any of those self-referential pointers point to keep that struct coherent, even if it's moved another location in memory. Or if you could just prevent it from being moved in the first place, you don't have that problem. Rust has no capability to either run logic to do fixing up at move time or prevent moving in the first place. And pin is kind of a hacky library type to do the prevention of moves. Anyway,
Does
just
the
some
Rust
background.
compiler automatically do this changing of pointers when we pin a struct?
No.
No.
For coroutines it generates, it implements the trait. For anyone doing any type of manual implementing the generator API manually, you have to deal with it, and it is not great from an ergonomics perspective because there's a lot of stuff that stops working when you're pinned.
Also, as kind of an expansion on, as an illustrating example, if you take a reference to a local variable within a coroutine and then hold that across an await point, you automatically have a self-referential struct. Because that local variable is supposed to live in the struct, so is the reference living in the struct. At the await point, both of those have to be stored in the same struct in order to yield.
That makes sense. And I I think I kind of understand the concept of using move constructors to get around this pin restriction that Rust has. Has anyone ever done this? Because I'm skeptical that one can actually use move constructors to update an entire self-referential struct deeply, especially if it has what are they called? Like type erased existential trait objects, interface references into the heap. Like, I don't know, I just can't fit my mind around updating an entire possible hierarchy of data to be pointing not into one quote unquote stack space to another quote unquote stack space. Has anyone done that?
At the point that you're lowering all of this into a single context struct for the coroutine, you must, in the compiler, necessarily know the types of everything living in it, or whatever, if you have a union type of what possible types could be in it, and hopefully which one it is. If you have a, say, something behind a vtable, a pointer to a trait object, right? That type does not require reference fix-up because it doesn't have to move. Only the context struct would have to move.
It doesn't have to move, but couldn't it have pointers into the struct that is moving? We can take
I
this
think
offline.
Rust declares that undefined behavior and doesn't deal with it.
Oh, okay. Can we do the same thing?
Yeah. I think that particular case is something that if you wanted to have that reference, you would already need the lifetime bound on it, and you would, in Mojo, you would need to know the origin for that reference, which if you have an opaque trait object, that can't exist. So I think that's almost inexpressible without automatically stumbling upon undefined behavior.
Okay, that sounds promising. Let's look into that more offline.
Yeah.
Thank you for answering.
Yeah, and for a slightly more pedestrian example of fixing up self-referential structs as you go, the newer C++ 11 stood string with a small string optimization. It is self-referential and fixes itself up as it moves.
I did not know that. I'm going to go look into that. I'll stop hogging the questions if someone else wants to ask.
Yeah, any other questions for Owen?
Okay. There are no more questions for me. I'll just say I'm happy to have chats with the team. if they would like to discuss this more, or if they would like some of the technical details I've omitted here. Um, Maybe I can explain it better in person than in Markdown.
Awesome. Thank you so much, Owen. That sounds great. Cool. So now I'm going to hand it off to Brian, who's going to talk to us about his project called EmberJSON.
Okay, thank you. Takes the screen. Oh. Okay, so I managed to pick the same background as Owen by mistake, not on purpose. So, yeah, this is going to be about EmberJSON, my pure Mojo JSON library. So first of all, just do a quick bit about me. Canadian C++ developer, currently working in cardiac imaging processing software at a company called Circle Cardiovascular Imaging. Lots of fun stuff. We do a bunch of machine learning stuff. I'm not a part of that, but we kind of we are in that kind of sector. And I got started with Mojo because, as many other people, I started programming with Python. I was, even though I don't really use it anymore, I'll forever have a soft spot for it. And I think it was Chris's interview with Lex Friedman about Mojo that first got me hooked. Just and kind of just like, wow, like something like Python, but so much better. Like this is going to be awesome. Um, and now, a couple of years later, I'm kind of using it on the regular, which is pretty great. So first of all, kind of why did I go down this road of building this? First of all, you know, JSON is used for almost too many things, but used for lots of stuff. And I noticed a mature solution didn't really exist yet. Lots of kind of like small code snippets, but nothing like really mature and well tested. So I figured it'd be cool to take this challenge on myself. And I've kind of found that building parsers is kind of fun. Actually, it's kind of cool and makes you feel powerful to turn plain text into like useful things. Um, and kind of when I was investigating what the state of the art is for this kind of thing, I noticed there's lots of use of vector instructions, um, and mostly written in C++. So you end up with lots of duplicate code. Like for instance, I'm going to reference the SIMD.json library a lot, um, which supports several different architectures. And for each one of those, it needs its own like SIMD wrapper struct or class type and every sort of vectorized operation needs a separate implementation for each architecture. And it's just a whole lot of duplicate code and probably pretty difficult to maintain. And you also end up with obviously limited platform support because you can only support what the maintainers of the library have the time to do. And if you aren't running on that platform, either you don't get to use it or you're stuck with some slow fallback scalar implementation. So since that sounds like something that's right up Mojo's alley, with doing sort of generic cross-platform SIMD programming. So why do not just directly port something else? Well, first of all, I'll be honest, I thought about that at first, and it turns out at the end of the workday at 9 p.m., trying to read sort of state-of-the-art vector code that I don't have a lot of experience with didn't go so well. And so instead, I decided to sort of take a step back and let's just try to make something that works, follow the old phrase of make it work, make it fast, make it beautiful. And that ended up really working really well for me because turns out when you just get something down that works and you can write a bunch of tests and a bunch of benchmarks, then you can kind of go back and sort of refactor fearlessly. And what I've been doing since then is just slowly piecemealing these more complex parts back into the code base, and sort of incrementally improving performance. Like for instance, taking sort of the fast float parsing algorithm from SymD.json, and vectorized string parsing and stuff like that. And so kind of just as a example of kind of why writing this kind of code in Mojo has just been so wonderful. So this is kind of the bread and butter of any of the vectorized parts of my code base, where we just have the generic sort of a byte vector of whatever the platform width is. And then so you can take stuff like this, which is a function from the Sonic CPP library for getting the non-space bits in a sequence of characters. So it just allows you to skip white space, like multiple contiguous sections of white space really fast. Obviously, lots of complicated vector instructions. It's kind of looks a little bit ugly. And then kind of a semi-equivalent Mojo code looks like this. So it's like 3 lines. So maybe not necessarily, I don't know if it's quite the same in terms of performance, but it looks a lot cleaner. And yeah, just a lot more maintainable. So now I'm going to just take a quick rotation into just a quick little just overview demo. So as it is right now, basically the sort of foundational types of the library are a value, which can just be any of the valid JSON types. I have a sort of a empty struct just to represent null, and then we have array object, and then a top level JSON struct that's just confined to being either an object or an array, because those are the only valid top level sort of JSON values. So for parsing something, we offer a parse function. You give it a string, and it gives you back one of these JSON objects. And here we're just extracting the array type from it. And here there's a bunch of sort of overloaded stuff, so you can index it directly. Everything is sort of readable and representable, so you can print it out easily. And you can access the nested object. You can mutate it, and value has implicit constructors for all of the valid types, so you don't have to wrap everything in value. And also none will get implicitly converted to null. So Python people who are used to being able to using that can just use that as they are used to it. Yeah, and also we do support both signed and unsigned integers. If at the moment, I'm not sure if I'm going to keep it this way, but at the moment, if it overflows, it'll let it. It won't throw any exceptions. So that could be a foot gun that I should fix later. But we also support some other just fun stuff like handling Unicode. So if you give it an escaped Unicode sequence, it'll decode that and give you emojis when you print it out and stuff. And as well as porting the fast float parsing from SymD.json, I also recently ported the slower fallback implementation. So you can do stuff like truncate very long decimals. It can still handle that nicely at least. As well as pretty printing. So by default, it'll just give you 4 spaces at each level. But you can also give it some other random string if you want, just for fun, or you can set the spaced indent level to something else of your choosing. So for as far as the future plans go, would like to support arbitrary length numbers at some point. It's not really something that's in the standard library, or I don't think anyone's implemented it yet. But the JSON standard doesn't technically limit the length of numbers. It does warn you that most implementations won't support anything over a certain bit length, but I think it would be interesting to support them nonetheless. Obviously, we need to keep making performance improvements. It's been steadily improving, but there's still some pretty obvious bottlenecks, and we're not really approaching the state of the art yet or anything. So still lots of room there. I'd also like to add, streaming API for large data sets and stuff like that. Right now, everything you just have to load in the whole string to memory, which might not be logistically reasonable in certain cases. And also structured parsing, kind of maybe like a SERD type interface with like a decorator. Obviously, that needs language support for reflection before we can go down that road. And that's it for me. Anyone have any questions?
Thank you so much, Brian. That was great. Any questions for Brian? Oh, and you can also install EmberJSON via Magic through the community channel. So definitely check that out.
True. Yeah. Please check it out and tell me all the bugs you find. So I've already had a few people use it and come back to me with feedback for things that I haven't thought of. So it's been really useful.
Yeah, for sure. Maxim?
Hello. Does the library support JSON 5?
No, just standard JSON at the moment.
Oh, I see. Thank you.
Any other questions? All right. Well, thank you again, Brian. This was great.
Thank you.
I'm going to hand it over now to Martin, who's going to talk about Modo, which is a great name.
Thank you for the invitation. Nice that I can present my hobby project of the past year. So I think you should see my screen just to get rid of some of this Zoom stuff. So yeah, it's called Modo. And so what is it actually? So it's Node.js written in Mojo, you may be wondering. But it's a Mojo project for Mojo developers. So actually it is a doc generator for Mojo, but it is written in Go, primarily due to the support for JSON and for templating in Go. So it's there. But what can it do for you? So currently to create API documentation for your project, for your package will get. So we have the Mojo doc command, which provides you with a JSON extract of the documentation of your code. But humans, so I built a Modo which consumes this JSON. It creates Markdown that you can then feed into a static site generator, like for instance Hugo, or probably also some other tools to create an HTML website from it. Further, it can also extract so-called doc tests from your code. So your code examples will be converted into testable Mojo code, which you can then run with Mojo test. And yeah, all these steps can be performed by the tool with just one command. So maybe next show a little demo that demonstrates how it is to set it up and to get it running on your project. So as heard about EmberJSON, I will use this one, like just taking a random Mojo project. So let's create a fresh directory. So see, I have an empty directory here. I will clone EmberJSON. The git. So I'll cd into the project. Just call the modo init command and give it format that I want, which is Hugo, for instance. So for the Hugo static site, will analyze your project and will set everything up. So basically that's it. And now you can already run the modo build command. In this case, I will disable the reporting of missing doc strings because otherwise we will not see anything else, just a lot of missing doc string warnings. So it runs background, gets the JSON, tries to extract some tests from it, but there are none, gives a warning about re-exports. You will see what this is later. And tests, but there were no tests. And now you can simply just run, for instance, Hugo. So I'll use the Hugo serve command. And we can go to the site that is shown here. And it's this served on localhost. You see a landing page with just some information for now. You can fill this later. And here you have the package. And you see that it looks like the API docs for the standard library. I also tried to use the structure for everything. So let's go into some module here. There should more text here if you have some doc strings. And here maybe the JSON struct. Right, you get a list of all the methods, and yeah, it should look familiar to you, just like in the standard library API docs. Of course, yeah, here's very few doc strings here. So maybe just briefly show another example. So in the user guide for Modo, there is also an example docs, and this is how it can look like with some more doc strings and with a little bit of Hugo styling. So we can have a look at this struct here, and yeah, down here we have some nicely collapsed detail and so on. So basically that's the basic functionality, but there are, and that's what I would like to show next. So get this out of the way, which formats does it support? So currently you can have plain Markdown, so you just get a tree of files, of Markdown files that you can use with. Then there is full Hugo support. You have just seen this, run the command, and then you can just build your docs and serve them with Hugo and then customize it on. Then further, there's full support for MD book. You may know it from the Rust book and other Rust documentation which uses it. But to know what tools you would like to use for the last step publishing, and I would be happy to integrate them into my tool. So yeah, let's get to the real features. So Modo provides a very simple syntax for cross-references within your package, which resemble Mojo imports. Like here, for instance, this is a simple cross-reference, the same module, and this will be transformed into a proper link, of course. Then there are absolute references, which always start with the root module. And also have some custom text by just having a space and then add your custom text that you want to original name. Yeah, then there are re-exports. So if you have a package that is deeply nested, you will add in the package init file have some which makes the package look like this for your users. So they have short import paths, and like structure and everything is already on the package level. And this is what Modo can, but currently that needs to be documented with such a small exports. Maybe that's something that Modular could change by including the re-export into the JSON. Then there are the doc tests that I already mentioned. Also quite a simple syntax. So you just need to label your code blocks with test identifier. Then you can also have hidden blocks like here, or global blocks that are not packed into a function in the tests. And in this example, what you would get in your Markdown output. So basically the hidden block is removed. And you will also get a file, so a test file, which contains all these blocks with the same labels concatenated. And due to the global blocks, you can also have imports or struct definitions or something that you can't put into a function. And then you can just run Mojo test over those files or let Modo do it automatically. Yeah, then I just said you can let it do Modo automatically. So you tool also with some scripts, so bash scripts that run before and after certain steps. So for instance, this is the standard setup that you will get that before you run anything, so a doc tool is executed to extract JSON. Or here, this is what is by default run after test. So we run on the generated test files here. And finally, the tool itself, or the Markdown output of the tool itself, is very custom, heavily relies on text templating. So if you have ever used Hugo, this is familiar to you. So all the output is configured like this, and you can overwrite stuff. So you can just make a copy of the template in your own template folder, modify it. As you see, it uses this nested temp to keep things structured and to make it modular. So you can maybe here just overwrite the summary, and then the summary of everything changes and so on. So highly customizable. So I'm through with these basic features. So how can you get it? So it's currently available with pip under name PyModo. You can install it with Go and in Go, and you can also download precompiled binaries for manual installation. Not installable with Magic, but I would really like to have it also in packages. So I think that's one of the next steps. And yeah, so I also have some requests, ideas in the direction of modular. So great if you could come up with a specification for the cross-reference syntax. So I just something, I tried to keep it easy. Maybe that's even worth a proposal. But generally, it would be good to specify that so that other tools can also use the same syntax. Try to have the re-exports or the package level imports that also in the JSON, so that we don't need to have this information of putting it in the doc strings. And yeah, it would be great just a tiny to have support for markdown lists and raises sections, because if you list, there is an arrow for the all gets just concatenated to one paragraph. Yeah, so and how can you contribute? Yeah, the most important thing is that it gets used and that it gets tested. And I would be really happy to get some feedback on the tool and also on the documentation, which is already, I think, quite comprehensive. And there is also a user guide. You've seen it briefly. And yeah, create issues and PRs if you have ideas, suggestions, and so on. And yeah, so thank you for your attention and looking forward to your questions or discussion.
This is awesome. Thank you so much, Martin. I think we had a hand
Thank you.
from Maxim.
Hello. I had a question regarding Python. I mean pip. So as I can see, we can both get the tool prompt or using Go. But as far as I can understand, they both get compiled by Go. Is there a reason behind Python?
Yeah, and it's just that I think it's easier for Mojo users because they will probably available and they don't need to install Go or manually install the binaries. It's pre-compiled, so it's basically just the binaries compiled with Go and packed into a tiny Python package.
Python wrapper.
So it's
I
not
see.
compiled. It's currently not compiled on your local machine. It's already in the package.
Yeah. Thank you.
Thank you. Any other questions for Martin? Going once, going twice. All right, well, thank you again, Martin. Awesome.
Thank you.
We have a couple of questions that were submitted before. We're going to answer one of them live, but you may have noticed we are missing Chris and a couple of other folks today. So the rest of the questions we're going to answer in the forum, just offline. And so let me share my screen for this one. So we have this question from Jeremy. I don't know if Jeremy is here, but the question is, Mojo's lifetime tracking so far seems to be a great compromise between safety, performance, and especially ease of use. How will Mojo handle lifetimes that can't be tracked at compile time, like circular references? I think Connor here is gonna talk to us about this.
Hello. Yeah. So the short answer here, I assume the person answering is Jeremy. You maybe know a little bit about Rust, given the question. But for folks who don't know, I mean, Rust's origin tracking system is quite similar in a lot of ways to Rust, and we think it improves in some ways. But the broad strokes, it's quite similar. And that means that the short answer in how we're going to handle things like circular references probably means we're going to need a lot of the same kind of standard library type what would you say, kind of escape hatch abstractions, if you will. So that's things like arc, mutex, refcell, etc. These things that essentially allow you to shift lifetime and pointer ownership from the origin/lifetime system to an actual dedicated type that manages an object or manages a pointer to an object. I mean, the basic reason this problem occurs is because, like in Rust with lifetimes, Mojo's origin system is kind of rooted. Things are rooted to stack locations, stack lifetimes. So that means anytime you've got some kind of object relationship that isn't rooted in the stack in a trivial way, you need some way to model that, some way to break out of that. And again, that's where things like arc and refcell and a lot of these abstraction standard library types come in. So if there's maybe a follow-up question, I'm happy to answer that. But I think the short answer is, at least baseline, we have the same problem Rust is. We'll probably solve it in a similar way. Now that isn't to say that we're saying we're just going to do exactly what Rust did, right? Like if people have other ideas, origin tracking is different from lifetimes in some subtle ways that I think we're still, even those of us who work on the language every day, are still trying to internalize exactly what the different implications are. It may be the case that we can kind of find a way to make some things that in Rust are a little bit cumbersome, maybe a bit better in Mojo. So always happy to hear folks' ideas and brainstorm about this topic.
Awesome. Thank you. I don't think that Jeremy is here. Jeremy, if you're here, say hi. I don't think you're here though. Okay. Cool. Well, I'm sure he'll catch the recording. Like I mentioned, we have a bunch of other great Mojo related questions that we're going to have answered in the forum, so keep an eye out for that. I will post the link to those threads with the community meeting recording too. Any other questions from the group though, before we close? Thank you everyone for coming, especially big thank you to our presenters. And yeah, the community meeting recording will be posted shortly, and we'll see you in a few weeks.